So in this video we're going to look at how you calculate asymmetries. We'll just focus on the lower limb. Now this is a real pertinent area at the moment because my colleague and PhD student Chris Bishop has identified that within the literature there are 9 different ways that asymmetry is being calculated, which of course is problematic when you consider comparing data across studies, also from the point of view of the athlete that might move from club to club and clinic to clinic. So really there's only one way that differences should be calculated. And if we give this some context, let's say the left leg produces a score of 3 units and the right leg a score of 2 units, the difference between them is 33%. And that's regardless of what way around that asymmetry is. The difference remains at 33%. Equally, the difference between 25 and 20 or 20 and 25, the difference is still 20%. Now, when you consider why there are so many different scores for 25 and 20 as revealed by Chris, it's because the investigators have also tried to use the equation to define the direction of that asymmetry. So right leg, left leg, dominant, non-dominant, or stronger, weaker. But in doing so, have then ended up with scores which really are illogical, because again, despite these scores, the difference between 20 and 25 is clearly 20%. And again, a really sort of crude and I guess silly example is if you was to walk into a bank and say and ask the cashier the difference between £25 and £20, she's not going to say, well, it depends which way round I divide the score. The difference is 20%. So this here is how you calculate the difference between limbs and between anything in general. To be honest, we need to do it with respect to the maximum score first of all. Hence, we have max and min, and this will calculate the percentage that the smaller number is of the bigger number. So here that would be that 2 is 66% of 3, for example. But then this second part of the equation just looks at, well, then let's calculate the difference off of that, which is 33%. So the difference, regardless of whatever way you cut that, is 33%, and here 20%. But the direction is really important to define, and if we do that using the if function, it means we haven't got to mess around with what the actual difference percentage is. So if we just, with the same equation, just bolt on an if function on the end, we can use the if function to say that if the score in the left-hand column is biggest, then put a minus sign, and if the score in the right-hand column is biggest, then just leave it as it is. Again, by default, we always go left and right. So hence we always know that the minus means left. Again, you can do that whatever way round you want, just appreciating that this column here is minus. Now that enables you to plot the asymmetry over time, and here would be scores for the where the athlete is right side dominant, and here would be scores where the athlete is left side dominant. So again, you can track the magnitude of asymmetry and the direction as well over time. So really the other asymmetry score that's gaining quite a bit of popularity at the moment is the symmetry angle, and that's so popular because it defined direction, so it used that minus score. But again, this is a score that's come from a clinical setting where you might get a measurement that's taken in multiple axes, and there might also be minus scores. So while it's valid in a clinical setting, it's not really overly effective within in strength conditioning. As an example, here the score is given in degrees. So no one will describe themselves as having a pay rise of 6 degrees, for example. So we should just make it very relatable to the coach and the athlete and keep things in percentage, and therefore report it like this. Now the only other way of looking at or calculating the percentage is if you're looking at change, so change over time. So if you're just looking at your back squat, how has your back squat improved, or whatever it is it improved over time, and if it's got better, or it might have got worse, and that's calculated as follows. So that calculation remains the same, but of course you've got the direction. And again, so here you might have left leg relative to left leg. If you was looking at left leg relative to right leg, you're back to looking at a difference again. So this is how percentage or asymmetry should be calculated.